Hello everyone, Peter here, Piotr Fissner. Guys, today we've got a special episode because the t-shirt thing. Look, fight for our right to repair. Yes, fight for our right to repair. It's still some changes will be made in here. Let's make it with Inte.Team. Yes, so we've got a t-shirt. I've got one more only. I've made two just to check, what to do, what to change, and so on. And let's do it. Yeah. What I wanna say is we've got a repair today, which is a laptop. A laptop with unbranded laptop, to be true. I don't know what the brand is, and I don't know what the model is. Just because customer didn't tell, and customer don't know. Customer completely don't know. It's looking like those laptops, cheap laptops bought at Argos or somewhere. It is what it is. But I want to show you what the problem is. I'm just checking if I can show it any better, but I probably don't. So let me switch to the screen here, the microscope. Okay, it's a bit too light though, too bright, yeah? And you'll be better off with no light. Okay, I can do with no light, that's not a problem. But you can't distinguish the difference in between two chipsets, which I want to point out. This and this. Yes, you can't see the difference. If I'll switch on the light, you might see the difference. No. I see, but I don't see it on the. I don't see it on the under the, like a microscope through the webcam. So what I want to say is the power is coming in here through the. I'll show you the board maybe first. That's the board. That's all. That's all there is. Look, that's my palm. Yes, I'll make it like that. That's a laptop. Yes, so that's not some fancy laptop. That's a cheap laptop. And yeah, so that's a CPU on the graphic card. So here we've got a fault. I'll plug in the power supply, and customer came with a power supply. I did check, and there was no 5 volts on that power supply. Yes, so this power supply which customer bought because he bought this power supply, it's a total rubbish. Or this power supply was shorted and didn't have any protection system. Yes, so when I'm plugging in USB-C, yes, this doesn't go off, so that means it's still on, so the light is on. Yes. Now when we check these pins, I don't know if we can. Do you need more light, or again, it's better off with no light though. Okay, so I can get my meter somewhere here so that you can see. I'll switch to DC volts, 20 volts. Okay, so you've got 20 on the DC volts, 20 max. Yes. Now I'll put my one probe here. Now on the pins number 4 and number 9 from my left hand side, we should have voltage. Yes, so if you count 1, 2, 3, and 4, yes, we should have some volts, and that's a 5 volts. So that's a proper one. Yes, 4, 5, 6, 7, 8, 9. You know the specification, so these volts are fine. Yes. Now here on this resistor, that should go to the battery charger, and that should be charging with several volts. We expect here at least those 5 volts. Yes, so let's switch to the other part of this board. So I've already checked that. And if you see on the on the battery, you've got come to daddy. You've got wires, which if you will check, you will see that you've got a red and black, yes, and in the center is doesn't matter, you know, because that's a battery power management, battery management. So you've got those red on the very left hand side when you plug that in, yes, red, and then on the very right hand side you've got black. So I'll plug that in. Okay, no, before plugging that in, yes, before doing so, let's check what the voltage we have over there. So again, I'll touch the ground somewhere here so that you can see everything, and I'll touch this pin, and again you've got 1 volt. That's it. Okay. So guys, I'm back. It's just that my son was requiring attention. So yeah, I'm taking my probes for this meter here, and what we're gonna do is we're gonna check this voltage which we're supposed to check. Yes, so we've seen that it's only 1 volt. Yes, 1 volt coming in, which is charging the battery. That comes from this thing, whatever it's called, yes, MOSFET or whatever, yes. So this thing should not give us only 1 volt. It should give us more than 1 volt, yes. I'll put more light because we can't see. Okay, I know it's not great, I know. I could get the capture card, yes. And look, on the right hand side it's only 0.77. Why it's less, yes, than here? It's 1.1 because of this component. That means this component works fine, yes, this MOSFET works fine. So now, if we know that the power which comes in from before, yes, is working fine through this via. You see those dots here? That's a via which is going somewhere through the board, maybe totally to the other side, maybe somewhere in between many layers probably, and goes somewhere there, yes. So anyways, that goes through this via. Now what's happening, if this works fine, yes, so in that case the power supply is faulty, yes. So the power supply we know was faulty. Next, the main power rail have a shortage, yes. When you press the button, you see that it's starting on and then off. So what I have found next was, again we are at the same place where the power supply is, here, yes, coming in, okay, and I found that those 5 volts are coming. So we are maybe like that. We are at the power, at the mains, yes? The main power comes into the socket. Now this one should go into main rail, okay? That should go to the main rail, and that should go to the battery charger, yes? So to that place where I've showed you. Now I found that this went up to here, okay. Here we've got 5 volts. If we check, you see my measuring, let's go a bit lower, yes. So let us grab this ground here of this thingy, and let us check volts at the top of this. You see, okay, I've got different connectors because I've got black on red, so you see minus, yes. But if I will change, the black one will go to the port and as a ground, yes, and properly, and this will go to the top. We see that we've got 5 volts, yes. So happy days, you know, we found our standby voltage probably, yes, or the power supply for the battery charger, yes, one of the things. But guess what? Let's check what's happening when we press here. Oh, okay, so this MOSFET doesn't turn on, yes? There are two types of MOSFETs, there are NPN and PNP, as far as I know. I don't know of any other types. If you know, comment it below, please, I learned something new. But I know only two types, NPN and PNP, yes? So I don't know this MOSFET at all, but I see that it got a 5 volts, yes? So, okay, no biggie, you know, no biggie. It doesn't go, it doesn't want to do anything, fine, you know. Next we check here, that's the outgoing from this, and it's going here, yes, so we got nada, nothing. And again, we've got 5 volts here, nothing outgoing. Of course, that's nothing, yes. Now the question, why, when we switch it on, why it doesn't want to switch on, yes? So it goes through, usually it's a pair of MOSFETs, yes, 1 and 2. Sometimes you will see them, they are the same, but many times they might be like a lower and high MOSFET, depend on the, you know, on the schematics, yes, what they trying to achieve with them. And then you've got resistor here, yes, and then you've got the second pair of MOSFETs here. Now what I have found is, well, you can't see me touching to the ground anymore, yes, so if I will just do like this, nothing happens, yes? But if I will switch off the power first, okay, and I'll switch to the diode mode, which is here, okay, I'll leave it with you. And now when I'll touch these probes, and everything will connect fine, because this meter is from 1990s. It's beeping, okay? So now what we can do is we can find the ground here, because that will be better. I'll try to find the ground. Where I am. Here is the ground. Okay, so you can see me that so that you will know that I'm doing it for sure, you know, not just talking, but doing. Trying to find the ground here. Now we don't have this ground. Okay, anyways, I won't be wasting your time. So we know that this was going through those two MOSFETs, yes, 1, 2, then goes through this resistor with 10 ohms, yes. So next, after this, we're going next, yes. So this power goes through this pair of MOSFETs and goes into the coil. So we expect this coil, you know, to not have short to the ground, because if this coil will have short to the ground, then that's mean it's a shortage. Somewhere in those MOSFETs it's a shortage, yes. So let's touch this. Do you see it clearly? You should see it clearly. And no, we get 500, so it's not no shortage, yes. But yes, but when we switch on the power on it, we get 0, yes. So that means something on the way is shorting. So again, I'll put black on the ground, and I'll check the right hand side one now, yes. So let's check the top of the right hand side. Nothing, it's 1, so that's good, you know, that's good, brilliant, you know, we don't have a shortage. We can check it versus this, nothing. Can try to, because that's the same what's here, yes, that's the same what's here. Then I can check like this, and we got 1 plus, and the opposite way, just to make sure, yes, 1 charging, and it's 475, brilliant, you know, good one, 476, 7, yeah, slowly but steadily. Now this one, yes, is the same coil versus this one, yes, So here will be shortage, of course, yes. But here, no short. Look, 0. I mean, you know, open. Yes. So now let's check this versus this. Nothing. Yes. So in theory, it's fine. Let's start the ground. Yes, fine. Okay, and let's touch on this side. Oh, what's happening? Look, I'm touching the ground again. Oh, okay. So the current is going through the first two MOSFETs, then goes to the second pair of MOSFETs, and what's happening is it's a short. Yes. So on this MOSFET is a short to the ground. Now the question is it the signal coming to the MOSFET is shorted, yes, or it's a MOSFET itself? So let's check, because we see the capacitor here, yes, and we will check if that capacitor is shorted. No, that's fully loaded capacitor, so that's okay. Let's change probes left on right and right on left. Okay, let's do the other way around. Yes, okay, you see 452, brilliant. I'm happy for this capacitor. Maybe, you know, don't have 100% the capacity, but it's okay. Excuse me, I was wanting to get a sip. So, as we see, we've got a short. The short is here. So now, what we can do is we can desolder this one, yes? And because I'm no expert, you know, with showing how to, the problem only is that I can't hold it in the best position, and then those can fly away. I need to take photos always, you know, like a photo, which one where when, if they are flying off, and then I'm stressing out because I'm no expert in showing, you know, the technique of soldering, yes? Because I need to watch the camera, I need to watch the process, and I need to watch if none of these will blow away. So it is not a pleasant, yes, it's not a pleasant thing for me to do. If this would be a bigger chipset, then I could use a preheater, yes, but because it's a small, how we call it, small MOSFET, it's no point, and it's the same as it's here. It's 3000B, 3002, yes, so it's no point. But again, you know, I need to be careful, because if I'll damage it, you know, then customer won't have it on at all, yes, whereas now we know the short is here, and now when we will desolder it, we will see if the short will still exist or the short will go away. If short will go away, we know what the culprit is. If the short will keep on staying, then we need to check the next element after that, yes, like by following the lines. So it took me, you know, a bit to learn it, and hopefully you've got some value how I'm checking it out, yes, because there is no schematics for this laptop. We don't know the model of the laptop. We just have a general electronic knowledge, which is applied to the electronics in general, yes. So if you know how the rails are working, the power rails are working, if you will learn on one, you will be easier on the second one, yes, and then on the third one, and so on, yes. So the more you will do, the more you will understand it. But you know, like everything comes with a practice. So if you won't start doing it on cheap devices which you can afford to lose, like Xbox 360, for instance, I think it's the best, together with PlayStation 2 or 3. Those devices are super cheap because you can get them for peanuts. Sometimes you can get it for free, and you can learn soldering on them, yes, and then you can learn components, how they are built, how those power rails are built. There's always MOSFET, there are always capacitors on the side, yes, what's the function of it, yes, and so on. What is the difference in between Schottky diode or Zener diode or silicon diode in between them, yes, why and when which one is used. And then when you look at the components right now, you will know what's what roughly, yes? You won't know all the capacitance of all the capacitors, of course, but you will have a rough idea and you will be able to diagnose as I am doing, yes? So then, even though you don't have schematics, you can do a lot of work without them, yes? I'm fighting with one TV right now, I've got no schematics, and that took me, like a lot. Whereas this one, I took it with a customer and I was able to diagnose it quite quickly. That's why customer went, so I wanted to record it for you so that you can see it. Now hopefully there is a value for you. And guys, I'm pausing because I need to just desolder it, and then once it's desoldered we will do tests together. See you soon. Okay guys, so yeah, the job is done. It wasn't bad at all. It was a good regular removing, nothing extraordinary. Hold on a second, my system is too shaky and it's too noisy. Okay, I think we can go with it, yes? So we got this fella here, yes, that's the same 3002, so leave it aside. Okay, and let's see what we have done. We won't be cleaning it at the moment, we don't have paths shorted, so I know it's too bright for you, so I'll switch it off. Okay, anyways, we need to have a meter now on the diode mode. Again, one wire on the ground, yes, beep beep, it's fine. And let's check those top pins now. They are shorted, okay, and the bottom, it's not. So that's mean the short, yes, as I understand it, the short is on this side. Short is somewhere on this side. The question is only what's causing the short right now, yes? And now when I look at it, I see that we've got a capacitor here, and here we've got some resistor or something, okay? I don't know why I haven't seen them. Now I see it, yes? So the question is, yes, no short. Remember that board is still hot, so okay. So here we've got no short, but again here we've got, and this one goes to here. Okay, so from this side it goes through the capacitor here, through this resistor or something, and then goes to this, okay? But we still got short, so removing this didn't fix it, okay? It didn't fix it, so keep it in mind, we desolder it just to make sure which side it is. Let us continue this journey. Okay, so we've got a short. Now we need to check this via, because I don't believe that these capacitors, because I was checking them for charging, and it's okay on the other side, no shorts. Yeah, no shorts. That would be too easy, yeah? But we've checked that before. So okay, so we still know that on this line here somewhere we've got a short. So now we can either inject voltage here in this line, or we can try to check this via where it's going. Yes, and see what's in it, what's in that via, where it's going and so on. So I need to mark myself with this, okay, because I won't know, and I'll have to lift it up because I don't know where I will. Okay, it's here. That's somewhere here. It's my finger. Okay, so we got 5 dots here. No, 6 dots. Those are the 6 dots. No, talking rubbish here. Here are 6 dots. 6 dots from underneath. Yes, so that would be the thing. So where do you go? I've lost it. Guys, I really lost it. I've lost it, I need to go again. I thought it's here, but it's 9. So, yeah, that's what it is, you know, unfortunately. So what do we want to look again? Okay, it is 9, but it is 6. So on the 9, there will be, in the direction of 1, there will be underneath 6. And on the one side will be drained for the MOSFET with the solder. So again, 9, 6, 1, so it's here. So it is here, but unfortunately we can't track it down because these via are not going here anywhere. So this is challenging because we don't know you know, where it's going. So there are a few ways now to check it, because as this is going somewhere in the inside layer, not going straight through to us, we can now do several things. We can check each power supply. What I mean are those coils. Yes, each of them, and check for shorts again. Because if we see that the power comes through here, you know, power comes through here, like these two, this didn't go, yes, didn't let go. It didn't have the, how you call it, it didn't have the short, but it didn't let go. So we don't know why there's no power in it. So we knew this one was shorted, yes, we removed that, and now I neglected this one, which had a power coming in, 5 volts coming in, and nothing here. So let's do the, I don't have short, so let's do this. Excuse me. Where was the diode? Power diode, I think here. Yes, these are the diodes. Okay, so we've got a power plugged in, and we've got a, okay, now it's on. Now it's on. Get a power here. We don't have a keyboard, but we still have this, so we can still check if that changed anything. Oh no, red on white, black, black on red. So we should have 5 volts, but I need to change my meter to DC 20. Okay. And now to the ground, or here, it doesn't matter, as long as it's quite comfortable to reach. So we still got 5 volts here, that's okay. Now you get 0.01. This, I've forgotten about this one. Why this only gives us 1 volt? Do we have a problem with this? Because this should give us full power, that means 5 volts. So if I'll put the impulse here, okay, let's take it to the ground, let's take it to the gate, I think okay, the other way around. Let's put here, okay. Oh. I can't activate it anymore. What I was doing, and I was, now it's 4 volts. Okay. I've forgotten which way I was activating it. So it's 4 volts. It doesn't give even the full 5 volts. Okay. Oh, now it's giving us minus. It shouldn't be minus here. You know why it shouldn't be? Because here at the top we get 5 volts coming in, and here is it's not minus. It should it shouldn't be. It should be and that's minus as well. So we get Houston got a problem. But now the question is it this faulty or is it this fault? Should I desolder this or this? Okay, I'll check ground here, because this has 5 volts. Good, minus, because I got a red one on the ground. Now it will be proper one. So now it's 5 volts. Now this one doesn't come out anything, literally, so it receives power and doesn't give anything. Same as here. If we can inject 5 volts, 0.76. Why only 0.76? So now the question, you want to go out or you want to go out? See, that's what I'm telling. I'm no expert, yes? I'm no expert. I know how to diagnose them and so on. I know how to fix, but I'm no expert. But if the voltage is coming here, yes, if the power is going here, it should go out here. Okay? That should be in between ground, so that means we touch the ground. Here we touch the ground, yes, with this top left this. And then here we got 5 volts. Now this should go out here and give us 5 volts. It doesn't, okay? It doesn't. Now, again, here is a bit different story, because here you see the drain is here on this pin, and it comes from here. So here it comes only 70.76 volt. So it's not enough. And that's why later here on the charger, where you remember we were pressing this one against this, and then this MOSFET was given only that 76. So we've got a shortage here as well. Okay, so now we need to get rid of one of these, but I need to make a break and desolder it. Yes, so I'll be right back. Okay guys, so I had a wee break. I had to have a wee break, but at the end of the day, what I can say about this one was a bit stubborn one. It was not letting go, and I'll show you why. You see this big pad underneath? That didn't want to, you know, heat properly, yes? So it took a bit more time. If these are faulty, like properly faulty, they can melt into the main board, yes? So that is a bad thing. This one is similar. Yes, this one is similar, but this wasn't stuck as much as the other one. So that's the previous one which I've done, yes? So now, what we see here is we got this space, yes? Now this space has those 4 pins together, this pad, yes? Then these 3 pins break, and this drain, yes? Here. So what it is now is if we can put 5 volts onto this place, we can see what this one will do. Okay, how many volts it will give us. So I need to put my digital multimeter, but I need to get additional probes for it. So ground probe, we don't need a ground probe because we can just hook it up to the port somewhere. Oh, hook it up to the port, it's fine, but we need a red probe, which is not fine. This one has to go in. Okay, so get a red probe. Now I've got 5 volts on my meter. I'll show you that. On my power supply, yes, bench power supply, let's switch it on. Okay, so we've got a 4.95 volts, okay? 5 volts, and now what we will be trying to do is we will be injecting those 5 volts, which should go normally anyway to that place if the MOSFET would be there. Yes, go away. So what we can do right now is we can make sure that we get 5 volts. Okay, so let's put this probe onto minus somewhere, and let's connect these 2 probes. And yes, we've got 498, and it's showing on my power supply that it's 494.9. Yes, now it's showing on my one 5 volts, so I'll leave it on 5. And now I know that in the red probe, additional red probe, I've got those 5 volts. Okay, so I can put this one somewhere like this. Okay, to take this one away because it's disturbing me. Okay, so with a left one, with a left probe, yes, I need to touch to this. Oh, and that was sparkle. We sparkle. And then with my left one, that's still 0. Oh, I was touching. Oh no, I think I know I had the sparkle. Oh, Peter, shame you. Okay. So what we can do right now is I didn't plug in the power supply. Okay, so guys, first foremost, yes, we need to correct things. Get the 5 volts, get the USB, get the power in. Okay. Let's do this. Okay, so what do we have right now? Okay. Now, do we have a 5 volts here coming in? We don't. Either my meter is wrong or we don't. Got a 5 volts here. Where's my left probe? Oh, guys, I'm doing rubbish. I didn't use my probe to the meter, and I'm wondering why I don't have. Okay, so maybe I didn't do anything bad. Maybe just, you know. And now I've got a minus on my probe. Now I should see 5 volts. Yes, everything's fine. Okay, so now this one, yes, this one here will have 0 volts. And now the question is, what will happen if I'll add here to this 5 volts? Okay, now the question is, so I'm adding those 5 volts. Can I do it so that you can see it? Not sure if I can handle it. See, that's the problem with camera. Yes, that's the problem with camera. I really try to make it so that you can see it. Okay, so it is touched. It is touched. So I should see here 5 volts. Good, but I don't see the bottom of it. Now we've got a 449. Now it's okay. So the problem was with that MOSFET. Okay. So now I'll check. I will tell you, but I don't wanna. We still got issue with the power supply, but it's because we get that. So we had 2 issues with 2 MOSFETs, separated issues. Okay. Now, to be true, we shouldn't short MOSFETs, but for the test purpose, we can. Yes, so we can. We shouldn't like leave it permanently for the customer to go with it. Yes. But if we will short, I'll switch off my power supply, and I want to point you out. So, and we can switch off this 5 volt as well for this laptop. So what's happening? Here is a drain. We can't connect the drain with the power because the power comes from here and goes to here. Yes? So now as we know that this power goes here and goes to here, we had the issue with that, and we got no more issue with that, yes, because this this MOSFET, yes, which didn't let go the current, it's out. It's out, so we need to replace it. Do we have it? Well, we don't. So what we can say to the customer, let's wait a few days, let's order it, and let's see what the next fault is, yes? Well, no, we don't have to. Why? Because we know that if we will short this one to this, we can see that the current will flow from this to this, yes? which is okay. Next, we don't have this MOSFET as well, because that is the same story. Yes, same story. It was shorted to the ground, and it still is. So I need to make sure why the short. Yes, so let's first test it. Let's unplug this power completely from this board. Okay, we got no power coming to this board. Let us get to the diode mode, diode reading, and I see that you don't see everything on the screen. Sorry for that, I didn't point my attention well. So anyways, is that better? That's dark. So a bit more light is better. Okay, anyways, so we've got this here, yes? Now, in between the ground and in between this, we still have short. So that's probably, you know, what caused is we've removed these two, but it doesn't mean we've got short gone, because there are two things. Something is burning because of the short, and something is shorted. So even if we remove these things which are not letting go, because they were shorted, you know, they were burnt, yes, in a process, but we still got something which is causing the ground, and it's going from somewhere from the board. So now we know that power was coming in here and was going through to this MOSFET let go, and it was fine. Now we know that we've got a power onto here, and it's going next to this, yes? So now what we need is, we need to short this one, and we need to short this one, and we need to find where the short is. Because if we won't remove the short and we will just blindly connect this, we will break something, yes? Now we can do the voltage injection, yes, as I've done. We can do voltage injection, but the question is where the short is. If nothing will be warm here, you know, nothing will be warm here, then we will know that the short is from here straight to the ground, which is bad, by the way. But anyways, I'll go, because it's after 8 p.m. and I've got other things to do, and I need to, you know, take my time and look for this short. So that's everything for the part 1, and as soon as I'll find the culprit, yes, what's shorting, and I will be, you know, like, I will be sure to remove it, I'll start recording the second video, yes, because we need to remove that short. We shouldn't neglect it. Guys, thank you for watching, and hope you've got some better understanding of those components right now. And yes, you shouldn't short MOSFETs. You shouldn't, yes? You shouldn't, because if you will be doing it, then you might end up in a trouble. Yes, so better learn basics, when and where, what, and then you will be able, in some of the cases, yes, or you will watch videos of some of the people. I don't remember now. I know that there is a one London repair shop. Guy is repairing, like a school, electronic repair school or something it's called, and guy shorted so many MOSFETs. If you would see, or other, you know, component like Zener diodes, he removed, you know, and he just neglected, he just left it, yes. And you know, it's fine, and this stuff is working. It's just that the protection is gone. You know, that's why these components are, yes. Like if you would use the diode here, well, it would work, yes, but the diode would consume more current, yes. So in that case we don't use diode, because that would use more watts. Can you use Schottky diode, which is, you know, which is using much less current? Yes, you could use in some, you know, in some projects there are, you know, Schottky diode instead of the how you call it, instead of the silicon diode, or instead of the other component, yes, the other components. So it is possible to replace things with things if you understand it. Yes, if you don't understand, don't swap things, because if you will start to swap things, you will make things worse than better. So hopefully you see something, understand something more that you did before this episode, and thank you for watching. Please guys, remember that we are fighting for the right to repair, yes? So you are with us or against us. Happy days. Yeah, but for real, thank you and bye bye.